Thank you. Okay, good morning and happy Halloween today. So let's enjoy my talk. Okay, so first of all, it's my great pleasure to give a talk today. And I also appreciate the group project member. The name of my project is Shizumeru Project. Shizumeru Project. Shizumeru is, the meaning of Shizumeru is calming, but with a feeling of respect to the nature. So I like this word. So, okay, and so this is the motivation that I joined this project. And this is a large eddy simulation calculation. And so my insist is the human activity sometimes accelerate the convection. So this purple color shows the vortex index. And the some vortex index is originate from the ground surface. So that means human have to reduce or human have to care the, this convection trigger. So that's my motivation. And the aims of this project is very simple. And this figure shows the life stage of growth of cumulonimbus cloud. And so we operate to weaken the roots of heavy rainfall so that the heavy rainfall will suppress intensity or the number. And also the LC or RRI research is very important, I think. So I think, in my opinion, that this RRI research should be basement of the technical research. And this is our team members. And we have 14 PIs and 3 teams. The team 1 is development of control devices. And we consider the 4 types of control devices. And the team 2 is real-time control system. And team 3 is LCA and RRI research group. And the important thing is the feedback structure. So what is the impact from the technical to the RRI group, and from RRI group to technical group, the social vision. So this feedback system is important. And so today, I focus on mainly the control devices situation, current progress, especially in this year. And in our project, we consider the 4 types of control devices, and offshore curtain, and wind turbine, and blower fan, and cloud seeding. Okay. And we are focusing on the following points in this year, 4 points. The increase the number of case studies to identify key operational insights, and advanced understanding of heavy rainfall suppression mechanisms, and consider reflection of realistic operations, and start, we have just started the in-house experiments and designing field experiments. So this is this year's main focus point. Okay, so first control device is wind turbines. And the target event is isolated convective clouds. So single, like a supercell. And so even single convective clouds can sometimes cause the flash flood, the left panel shows. And because in Japan, there is a very small river basin in the urban area, so we have to care even this single cumulonimbus clouds. And so the middle and right panel shows computer calculation based on large eddy simulation model. And you can see using the wind turbines, so rainfall intensity was reduced 17%. And in this calculation, we assume that two giant wind turbines. So I think this is a realistic number. And we conducted the many sensitivity experiments. For example, the duration of operation or timing of operation or intensity of operation on the many sensitivity tests. And as a result, the operating position is quite important. And this map is, shows the operating position. And you can see many grids. And this is operating positions. And the convection core is located at the circle point. And in this event, the main wind stream direction is westerly wind. And so you can see some numbers. So that number means a ratio of peak rainfall intensity to the no operation case. So that means less than 100% means suppression. And you can see the big suppression area is the upstream side of convection core. Okay? And, but on the other hand, some part, the blue color part, shows the increased case. So this is a negative result. So we have to understand the reason. And we conducted the 3 cases of isolated cloud convection case. And finally, we can get the right panel result. So this is a rate of change in precipitation according to the distance from the convection core to the operating position. And you can see the curve convex below, like this curve convex below. And the maximum suppression location is just outside the convection core point. So it's very understandable, makes sense result. And also the red color and green color shows the difference between the along the wind direction or off or side wind directions. So upwind, directly upwind direction is highest result. So it's also very understandable. And this is a schematic image of suppression mechanism. So the middle panel is a well-operated case. That is a suppression, big suppression case. So the updraft by buoyancy and updraft by convergence was separated by the wind speed operations. That's the main mechanism. On the other hand, the failure case, the increase case, was occurred like this one. So by wind speed operations, the new convergence, a new updraft by convergence was occurred inside the buoyancy area. So that rainfall intensity increased. So we have to care this one. And this is another viewpoint. This is a manufacturing or engineering approach of wind turbines. And we used scanning Doppler LiDAR at the real wind turbines test site. And the left panel shows wind speed distribution at 12-second intervals. And you can see dark red color. Dark red color indicates low speed area. And there are 2 wind turbines here. And the phenomena can catch. So typically, wind turbines are used for power generation. So typically, the blade orientation face directly into the wind. But in this project, we have to control the wind weak location. So for the next step, we will verify the effect of changing the blade orientation. And also, we will verify the cumulative effects of multiple wind turbines. That is our next goal. Okay, the next topic is offshore curtain. So this is new idea for heavy rainfall control. And this offshore curtain is controlled the aims of offshore curtain is controlling water vapor inflow to reduce the wind speed. And the target event is linear Rainbands, linear convective system. And so offshore curtain is suspended by kites, hung by kites. And currently considering the size of wind offshore curtain is 1 kilometer by 1 kilometer, very big size. And the advantage of offshore curtain is that the offshore curtain can be moved anywhere on the sea. And this is one result. And we applied the linear convective system case. And we can get the offshore curtain can be reduce the rainfall amount by 34 suppression. Okay. That's a very big change. And the similar as wind turbines case, offshore curtain, in the case of offshore curtain, the operating position is also very important. And in the case of offshore curtain, we can change the height, not only the location. And this table shows the sensitivity test. And mouseは出るんですかな。Thank you. And so we change the height location, and the horizontally location is X scale. And the blue color shows a decrease case, and the red color shows increase case by the offshore curtain. And basically, the high suppression area is confirmed when the offshore curtain is installed at a low height. It's also very reasonable result. And we applied this one for another rainband case, and the result is almost similar. But the too near the rainfall area is not a big effect. So important insight is a few hundred kilometers away from the rainband is very good operating position. And also we conducted the sensitivity test on the operating timing and the duration. And the panel shows the x-axis is the operating duration, and the y-axis is a changing rate. And so basically, the long time duration operation can make the big suppression effect. And also, the color shows the start time of operation. And so the number is seconds, so very difficult to understand. But here, this timing is the start of linear organization of rainbands. And after the start organization, so there is no suppression effect. So on the other hand, before the start of linear organization has a very big effect. So important thing is start the operation before the organization. That's also very important insight. And this is another viewpoint, the considerations of global warming. So this project aims 2050. And so we have to consider the global warming effect. And in the upper sections is present climate simulations. And the lower sections shows the pseudo global warming simulations in the 2050. So that means almost plus 2 degrees Celsius increase. And the left section is a no operation case. By the pseudo global warming test, the rainfall amount will increase by 26%. And we applied the offshore curtain. This is the middle section is 0.5 kilometer size, a little bit smaller scale. And the right panel shows the 1 kilometer size. And here, this is reducing suppression amount. And so one thing is that even 0.5 kilometer size offshore curtain can reduce the 15%. So that's also very nice result. And so one another thing is in the case of global warming, the offshore curtain has some effect. But we conducted the plus 4-degree increase situations. So the separation effect reduced. So only 6% or only 11% reduced. So important thing, we have to check the mechanism carefully. But I want to say, so we have to care the atmospheric condition in the global warming, because our target is 2050 or the beyond of 2050. Okay, that's the message of this output. And this is a wind tunnel experiment of offshore curtain. And so this bright part is a curtain. And you can see the reducing the wind speed here. And also the left panel shows tilt the curtain, because in the real case, the offshore curtain will float by the wind speed. So we have to check the tilting case. And this is one output. So we check the wind speed reduction effect along the streamline. So our purpose is the wind speed reduction keeps longer and longer. And the x-axis is the distance from the curtain, and the y-axis is a ratio of wind speed to the original wind speed. The 1.0 means the original wind speed. And the black dashed line shows a fully solid surface. So in this case, the wind speed reduced dramatically just behind the curtain, but the wind speed recovered soon. On the other hand, we changed the curtain type from solid type to the mesh type. Okay? And there is many parameters. And for example, 48% permeable curtain case, so wind reduction can continue for very long distance along the streamline. So that's very nice result. So we will develop the mesh type curtain. And left panel shows a particle tracking velocimetry result. So we can understand in case of tilting case, for example, the updraft by as a sub effect can be catched by this test. Okay, and this slide is engineering design of offshore curtain. And now we are calculating the designing the left side. And so this is the curtain hung by kite. And the top animation shows the kite test by Toyota vehicle company. And also now we are considering the tilting angle. So that is corresponding to how to hang the curtain. That's very important because it changes the tilting angle. And the next is third control device is cloud seeding case. Okay, the next one is cloud seeding case. So one big result this year is this one. So we checked the cloud seeding using beam model for cloud microphysical processes. And the cloud beam model can express the drop size distributions. And this is ice crystal drop size distributions. The upper section shows no operation case, and the lower section shows operation case. And just 1 hour after the cloud seeding, you can see the increase in small size ice crystals. And 3 hours later or 4 hours later, the gradually increase in the small ice crystals, like here. Instead of that, the decrease in big ice crystals. And this figure also shows drop size distribution, but graupel. And there's no big change in the 1 hour or 2 hour after the cloud seeding, but 3 hours after or 4 hours after the cloud seeding, you can see the decrease in big graupel, big size graupel, and also increase in the small size graupel. So that's the mechanism from a viewpoint of cloud microphysics. So summarize is small particles increase, and competitive growth state, that is overseeding, happened because of water vapor amount is limited. So that suppress the growth into the largest particles, such as graupel. So we checked this phenomena by beam model. That's a very new point. And duration is also very important. And for example, 1 hour is no big effect, but 6 hours is a very big effect. Compared that the modeling, seeding intensity has no big effect compared to the duration. So duration is very important thing. And the next slide shows reflection of realistic operations. So that is a flight path, because airplane cannot stay at a certain point. Airplane can move. So we consider the flight path. The airplane flies in the circular pattern like this, and a little bit shift. And as a result, pattern 6 is the best result using 2 aircraft. And one is from south to north, one is from north to south, at these regions. And finally, we can get the result of maximum rainfall amount was reduced by 70%. Okay. So this percentage is almost similar at the assumption that airplane can stay. So even we consider the realistic operations, the cloud seeding has an effect. And using these calculations, we computed the flood depth simulations. So this color shows the flood depth, and you can easily understand the flood depth area is shrinked. And area change of flood depth is averagely 25% reduced, especially high flood depth area was dramatically reduced. Now we are considering the timeline. So as a viewpoint of operator, and scenario analysis, and operator here. And the airplane is take off and go to the target point, and the scenario analysis again using the model. And the flight path. And estimated the deduction of disaster. Okay, now we are planning this story because we will clarify what is the missing parts. Okay. And the last control device is blower fans. So the purpose is suppression effect of heat transfer in the urban city. And this is a model town with different height of blocks. And using every large AD simulation model, we calculate the vertical profiles of wind speed and momentum flux and heat flux in the boundary layer. And so we can understand the heat flux was reduced by 23%. So this change was very big because the using a mesoscale model, we carried out many sensitivity tests, and so 20% reduction in sensible heat over a 20-kilometer area, so that's corresponding to 1 town, lead to the 20% reduction of rainfall. So 20% reduction of heat transfer is very important. Okay, and this is a last slide. And we participated in the Expo Osaka 2 months ago. And we made the animation. This is the future from a viewpoint of students. And I think this movie is very, very interesting, more interesting than my talk. And so please search the heavy rainfall control on YouTube so you can see. This is a 10 minutes movie. And so this movie is a good point. Good point is not only merit, but also demerit of the heavy rainfall control is expressed. So please check it. Okay, so that's it. I close my presentation. Thank you very much for your kind attention.
Thank you very much, Dr. Yamaguchi. So, dear participants, do you have any questions or comments?
Do you want to see the movie?
This is a very, very nice talk, and so I have one questions about the wind turbine for the blade. So is it? I mean, I'm sorry, I'm not familiar with this, but is it easy currently? Is it easy to, to change the direction of the wind turbine? For this setup, like if you want to change the wind direction, for example, 30 minutes before the rainfall, you already detect that you are going to take the action. Is that easy to do that in reality?
Mm-hmm. Yeah, nice questions. And so viewpoint from the mechanical technique, it's very simple, very, very easy to change our blade orientations. And reality, yes.
Yes.
Yeah, but from a viewpoint of forecast accuracy is another viewpoint. So we have to catch how many minutes can we get before the convection start. So that's another point. So anyway, the changing the orientation is very easy. Okay. So yeah.
Yeah, so I think then I have also a related question. As you mentioned that, I think the forecast accuracy is a important factor to initiate your intervention. And so I see it seems that the offshore curtain thing is also a powerful design, but it's so the wind direction and also the wind speed. So to determine when are you going to initiate this, will that be based on the forecast or and also how fast you can because some of that are ship based. So how fast you can move those ship to adjust that if there are uncertainty in your wind direction. Yeah, thank you.
Yeah, so that's a very important point, and my current answer is the first step is using numerical weather prediction, and we can go estimate a rough position or whether we will do operation or not by using the numerical weather prediction with ensemble prediction. But of course, the weather model has uncertainty. So the monitoring in real time is another very important point. And for example, yeah, this is a offshore curtain is hung by kite, and so we have a kite, so this can catch the if we set the sensor, we catch the real-time information about the wind speed or humidity or temperature something. So maybe combination of the real-time monitoring and weather forecast is very, very important. Yeah, but there is currently no detailed plan, so we have to consider that problem here. Thank you.
Other questions or comments?
Thank you very much for your excellent presentation. I have a few questions about the configuration of the wind turbines. So how large are these turbines in terms of rotor size, diameter? How far do you put them, and what size of area do you cover?
Yeah, thank you very much. And first question is size. The size is currently considered 200 meter or 300 meter size. This is corresponding to the biggest or biggest size in the current situation.
Is that rotor diameter?
Sorry?
Is that the rotor diameter?
Yes, blade diameter, yeah. Yes, and so in the single convective case, the only two giant wind turbines can suppress the rainfall amount. But in the case of rainband case, probably the more huge number of wind turbines are required. So, but fortunately, in Japan, we have many, and we have a big plan to install the wind turbines wind farm along the coastal line. Of course, the area is limited, but the main purpose is power generation. That is an important point. So maybe 364 days are used for power generation, but the rest 1 day is used for heavy rainfall control. I think that's a very reasonable. Yeah.
And what's the configuration? Like, how far apart do you put the different wind turbines?
Sorry, no answer now, currently. You mean the interval of wind turbines?
Distance between different turbines.
Sorry, no consideration. Yeah, thank you.
Sasuyama from the University of Tokyo. Thank you very much for your excellent presentation. My comment is again related to wind turbine. So have you explored, I think I saw some LC group, so I guess have you looked at the legal implication, or how are you going to do this? Because renewables are being supported by a lot of policy schemes, and and have you ever thought about this, like a legal pathway to get to that? Because and somebody has to make an order, and what would happen in terms of insurance? Because if something goes wrong, who's going to compensate? And just wondering if you have thought about these issues.
Yeah. So we cannot escape that problem, and but unfortunately, currently I didn't consider it, and in my feeling, so as a first step, we have to consider the philosophy of the weather control. This is the first priority, I think. So next step under this philosophy, we have to make the legal problem or economic problem or something. So I understand how to implement in the realistic society is very, very important. But I think this is the next step. So anyway, I understand your comment is quite important. Yeah. Is this an answer? Okay.
Questions?
Thank you very much for your excellent talks. I wonder if how much is the reduction of the heavy rain is sensitive to the initial conditions or some slight parameter changes. Could you tell me something about that?
Yeah, which case? Wind turbines or everyone is okay?
In any case.
Any case, okay. So, なんていうかな、wind turbines case, we check the 3 cases of atmospheric conditions, the different conditions, and
you mean the 3 different initial conditions?
Yes, yes. 3 real heavy rainfall case. So not many, but the common thing is suppression, maximum suppression effect is roughly 50% to 20%. And offshore curtain case, using 1 kilometer size has a big effect. It's a little bit unrealistic case, but we checked the 2 cases for different cases. But maximum effect is 30% reduction.
Okay, so you mean the variance is not so much big compared to the average reduction?
I thought that, but I applied for the global warming atmospheric condition. The answer is different, so we have to reconsider. Yeah.
Okay, thank you very much.
Thank you.
So it's time. So thank you, Dr. Yamaguchi again.
Thank you very much.